everything correct. Hello and welcome to the EPROM 9. Today's video is a teardown. We like teardowns. And we went on eBay and brought two of these. Now, I don't actually have a need for any outdoor lighting at the moment, so I hear you ask, what the hell do you want outdoor lighting for? 1, to take it apart. 2, I actually want another light up here, and something like this would be perfect. 3, I've got one more set of home-built solar lights that need a waterproof case. And it's currently pissing down with rain, and the electronics are completely exposed. And we are going to use one of these cheap-ass lights as a project case. From China, made out of stamped steel. You can very much tell from, well, the way the steel is. It's like, you know, sheet steel stamped into a mould. And we'll move all the various neon devices and whatnot that we've got sitting here, because I've been doing loads of experiments with neons. This is, for example, a neon multi-vibrator circuit, which is an oscillator basically that flips between two LEDs. In this case, it flips between two neons, but it still does it too fast. We need to slow it down. We'll find a solution to that. And the other one is Nixie tubes, really hooked up to relaxation oscillators. And we have a whole neon tube hooked up to a relaxation oscillator. Actually looks quite cool. The elements do kind of flick around, but not in the way I was expecting. It's a new, interesting way of doing it. Oh yeah, I'm completely overdriving this tube, but that's because I want the brightness, and it produces some interesting, like, purpley glows. I don't know what they are. But let's stop getting distracted by neons and nixes, which is my current latest obsession. I've been messing around with that and solar lights and other things. And maybe we should turn one of these 10 watts into a solar light. Yeah, it's some idea. So we'll show it to you running, but first we'll get the hoppy, because we want to show it to you running. But we want to, this is why you always want these on power strips that you can just pick up off the floor and shove between your legs. Hang on. Oh yeah, I love shoving rods between my legs. And we have the classic hoppy. My voltage is up to 333 volts now. Ooh, it's gone up. We'll get the Cliff quick test in and pop him in, because we want to look at the power. On the packaging it says, oh, you'll get power factor of like 0.9999. You will see that is all lies. Lies, I tell you. They're telling fibs. So we'll just pop him there. We might have to rotate the light round so it doesn't blind everyone. And we'll plug the quick test in. It's blinding me, yeah. That's a little too bright. We'll turn him round. So he's got a nice decent brightness, you know. He'll make a good lamp to mount to the ceiling. But this one isn't going to be that. This one's going to become the solar powered thing. And I just realised I didn't connect the quick test to the hoppy. So let's rectify it. There we go. Now we get the actual thing. So it's a 10 watt LED, apparently a 10 watt light. They're actually underrunning it at 8.8 watts, so I'm actually okay with that. Underrunning these LEDs actually theoretically leads to a longer life. We have a power factor of 0.53. So yeah, that was total fibs and lies. It wasn't anywhere near 0.9. We have milliamps of 71, and we have a new toy we can test that with. He arrived today. A UNI-T DC current clamp meter, which can do AC, DC. The reviews of it are actually really good, and I've wanted something like this for ages. So, shall we see what this says it is on the milliamps? It's actually pretty accurate. Right, let's see if I can get away with putting him down there without everything falling everywhere. Right, we're on that. It's on AC, so it's less fussy about that. that's alright, we'll just pop that open. That's alright. Cool. No, stay there because we want to measure the difference. Okay, we're back up to 71 milliamps on the Hoppy, and we have 70 milliamps on the UNI-T, which you can see. So yeah, the Hoppy and UNI-T are within reasonable ranges of accuracy, although I guess this would probably be more accurate. Although actually the Hoppy might be slow. Oh, the Hoppy swapped to 70 there. So yeah, that makes sense. And then if you do the maths, you'll find it's the same there. So we'll unplug him. And we'll plug him back in there. Hoppy can go away to one side. Back into his little cubby hole he now lives in. And we will disconnect him from here. Now, there is a nice thing actually to note about this, is when we check for the earthing, the nice thing is you can remove these sleeves, because there's a lot of probes out there you can't do that, and I've had to trim them off, which is the case on the ones on my fluke meter. There, the horrible light had to be trimmed off because, yeah. So yeah, I like that. You can put them on when you want them, you can take them off when you don't. This is already disintegrating, so that can be thrown away. Come with a nice set of cheap naff probes, which do the job quite nicely. Go to continuity. And look at that. Not only is it latching, but it's the best damn continuity set probes I've ever had. So here's our mysterious Earth. Now, the Chinese, to this day, have this bizarre, like, just don't seem to understand the concept of mains Earth, of mains earthing and mains isolation from the chassis. So when we do this, to our delight, the earth wire is actually connected to the chassis. So the Chinese manufacturers who produce cheap shit are learning, which is awesome. We like that. So yeah, get one of these meters, they're super useful. And he's also got good protection, so he's probably going to replace the fluke as my general purpose meter for all that good jazz. So we'll start from the front first. We'll brush the bits of solder out the way, grab a suitable screwdriver, because we're actually going to take him apart. We will also turn on the soldering iron, because this one's coming apart because he's going to be a solar light thing. So these are nicely screwed together, as you would like to see. Oh god, it's 8 minutes in, we've only just started taking it apart. But as you can see, well, I don't know if you can see it, but I can see it, the LED chip in a standard 10 watt LED is actually in a 3x3 case. We might even do a schematic depending on the type of power supply, which I suspect will be some kind of buck regulator. That's if it's not potted. If it's potted, well, I don't want to depot it because I can reuse it. So off comes the glass, and it's held in with... This is definitely silicone, these seals. But I'm not sure if it's like silicone they've actually just put into a mould and done, like out of the silicone tubes that these things dispense, because it looks very much like that. In fact, is this even glass? Yeah, it's glass. Teeth test. I don't know if it's this kind of silicone that's been done into a mould or not, but it's definitely some kind of like rubbery silicone stuff. It doesn't feel exactly like that type of silicone, but I could be wrong. So we put the front out the way, so that's clamped in, that's going to have decent watering. For some weird reason we've only got 2 screws holding the shroud on. I don't approve of that. They should use all the screws. But what do we have inside the front bit? Where the reflector lies. Oh, you numpty. The wire just knocked over my nice, neat, organised screws. No one else I have seen on the internet does their screws like this. It's only me. And boom, we've got all that space for the lovely little thing. And look at that. Oh, silicone wires. We like that. What voltage is that LED actually getting? Now this, I don't know if this is an isolated supply. If it's a buck, it's not going to be isolated, but I'm curious. What voltage is our LED getting? Is it 12 volt? Is it more? It's a 3x3, so 12 volt would make sense. Although then you'd want to use some kind of current regulator. So, hopefully this won't dazzle us too much. I'm prepared to have my eyes raped. But you guys don't have to suffer such a fate, so we'll knock that to DC. Really? Ah, good. That's just general noise, so... Boom! That's bright. Oh, Jesus, that's nasty bright. 28.6 volts is what that LED chip is receiving. Hang on. Let's try the hold. Oh, no, it's a rubbish hold. There we go. We're able to hit the button. Oh, that's rubbish hold. Seriously? You have to hit the button. You can't just hit it in... Why is it only flukes seem to know how to do the hold mode properly? Oh, Jesus, I've got blobs in my eyes now. Oh. Ooh, got loads of coloured blobs in my eyes. It looks similar to when you get a migraine, only it's television static on migraine. So my vision will slowly come back, but as we can see, it's run on that. Oh God, it's got that horrible heatsink compound in there. The LED gets reasonably warm. We could measure it with a thermal camera with some long-term testing, but I'm not really in the mood for doing that today. So we've got lots of room for our little solar panels. Oh, that cable looks green now. Right, let's pop off the back and have a look at what type of power supply we have in here. These screws are very wonkily done in the metal. You can tell that this is like, yeah, they're going into sheet metal essentially. Although this part is die cast. But most of it's made out of sheet metal. This is steel. That's aluminium, that's steel, the rear is steel, so that's prone to rusting. Always good to have a few neodymium magnets. As you can see, it's 10 watt. Well, so, yeah. Okay, yeah, it's not exactly 10 watt, but that's no bad thing. We pop it open, and unfortunately, we have a potted module. But we can do a test to find out if it's a buck regulator, which I suspect it is, using our new multimeter. Yay! We're getting lots of excuses to use our new multimeter. So we'll put them in diode mode. That beeping's a bit annoying, because you can often see this through these. I don't know if it's the live or the neutral you have to do it with. It all depends on the way round the diode is. Okay, let's try the neutral. This is making me suspect this might actually be a switch mode rather than a buck. because we're not getting anything between the live and the neutral. We're literally getting naff all. So that might actually be a switch mode. I mean, I could be wrong, but I did the diode test. So, can we get him out easily? We should be able to. Yeah, he's just held on with some silicone. Alright, how easily does this stuff come off? Oh yeah, this is just your standard silicone sealant-y type stuff. I wonder, does the alcohol method work with this? I know it works with hot glue, but I don't know if it works with silicone sealant. I somewhat doubt it, but might as well give it a go. No, it doesn't work. Okay. Bear with me, let me just pause it. Okay, we were able to get most of the crud off, and the input is your standard 175 to 265 volts, 50-60 hertz. Your output is, as we measured on the thing, 20 volts DC to 35 volt DC, 250 milliamps. Now there is one more test I can think of to actually determine whether this is an isolated supply or not. But I'm going to do some more testing off camera to determine that. Okay, this thing is definitely fully mains isolated, and I can tell you this straight here for a nice simple test. We've got neutral hooked up to this probe. We've got live going to the lamp, so if it was hooked up to the live, then it would light the lamp. So we've got standard 240 volt lamp there. LED, of course, because LED's awesome. We'll put some tape over here to give us our eyes some sanity. And lamp not lit. Lamp not lit. The thing doesn't seem to be passing any kind of live, and let's just turn this off before we melt through the electrical tape completely. Because as it turns out, that thing puts out a fuck ton of light. It's got bits of So this is actually a surprisingly good light, actually. I might link it in the description. It's mental bright, it's quite safe. I can demonstrate to you that the lamp does work. Boom. So yeah, that does seem to be using a switch mode isolated supply, which is double thumbs up. Earth hooked up. The thing passes all basic safety tests. And that is basically my teardown, because there's not really much point me showing you deconstructing the rest of it. But otherwise, I'm pretty damn impressed for an eBay light. Usually they'd be like completely dangerous and you have to do a whole load of modifications to make them safe. But in these ones, you can basically just install them up and they're perfectly safe to use. No modifications to do whatsoever. Which is absolutely awesome. And now I can put him back in my box of light bulbs, because I seem to have a collection of light bulbs under the stairs for some odd reason. I wonder. Couldn't be anything to do with the fact I'm obsessed with lighting, could it? Does make you wonder. Thanks for watching.